I'm going to do it on my computer, right? That's
the idea. Yeah, so welcome everybody. So this is a workshop on data visualization with R, and it's very basic. So I try to make it really accessible to beginners and intermediate users of R. So you don't need to have a lot of experience. So if you're advanced or you use R a lot, you might sit back and enjoy. There's not that much that you will probably learn, but it might be just helpful for you, to get some acquaintance with how you can visualize data with R. There are different ways that you can follow this workshop. So one way would just be to sit back and relax and just enjoy the show. And then basically after the workshop, you'll have access, or even now you have access to all the materials, and you can basically go through the materials yourself. Another option is that you download the data and also the RMD file, and you can basically then execute the code as we go and follow the workshop basically actively within RStudio. And the third option is I created a Jupyter Notebook. And the Jupyter Notebook basically has advantages and disadvantages. And the advantage is that you do all the computation in the cloud, which means that we get rid of all the setup issues that you oftentimes have at the beginning of workshops. And if you want to choose this option, then here is the link to the Jupyter Notebook. I just posted it in the chat. And what that does is it gives you basically, let me share my screen. Sorry. And the Jupyter Notebook looks like this, right? And now the good thing about it is that you can copy that and copy it into your own Google Drive. And then you can not only execute the code, but you can actually edit the code and execute code yourself, right? Now, the disadvantage from Google Collab is that the installation takes quite some time. So for example, when I install the packages that are necessary for today's workshop, that'll take a couple of minutes to install. So that's the disadvantage of using Jupyter Notebooks. But you don't have the problems with getting everything started and setting everything up. So that's the positive aspect to it, right? Now let me stop sharing this for a second, and I'll go into RStudio. And I'll share again so that you see what what it looks like when I open RStudio in this case. So there are different files in the repository, right? The repository should basically include this, and there's also lots of stuff that you don't need. But it's just handy for me to share everything with you. And the file that you can use when you want to follow this tutorial in RStudio is called wizcode RMD. So if you click on that file and you open it up, then basically you will see what you see now. And then what you can do is you can execute the code in RStudio. That's also an option, right? And here the installation is much quicker, but it also takes some time. So these are the three basic ways that you can follow that workshop, right? It's either you sit back and relax, and basically because everything's recorded, you can then watch the recording and do everything that you need after the workshop, or you can follow the workshop in RStudio, or you can basically use the Jupyter Notebook, right? And each of these has advantages and disadvantages. The disadvantage of sitting back and doing it by yourself might be that you encounter a problem, or if you got something, and then I might not be there to help you out, or Sergey or Natalia might not be there. If you do it in RStudio, you might encounter some problems with installation and installing some stuff. But basically, the installation works relatively quickly. And if you work with the Jupyter Notebook, then that should get rid of all the problems relating to the technical setup that you're having. But it just takes longer to install all the packages. All right. Okay. Now, in addition to this Wiz Code RMD, I also have a notebook that I called AcqVA Wiz Workshop RMD. I'll just knit this real quick. And what this is basically, it's a longer version of the Wiz Code notebook. In the Wiz Code notebook, this one here, what you'll see is that pretty much I focused on the code itself. So I didn't really give a lot of explanation because I wanted to basically condense it and give you a short version. And the AcqVA Wiz R workshop, WS RMD, that's basically a more elaborate version of the notebook with a lot more explanation. But you know, I thought it would be more difficult to navigate in that because there's lots of text, and that's why I created the shorter version. Now, because I've already executed everything here, I just want to get rid of everything and paste it back in there again. All right. Okay. Just out of curiosity, let me stop sharing for a second. Most of you have said that you have some experience with R, but not a lot, right? So just I'll create a short poll. Where I ask you, what's your experience with R? And I'm doing this as we speak. And then I'll save this. And now you should actually have the ability to vote, if that's all right. Where I just ask you, what's your experience with R? Do you have no experience, a little experience, or a lot? Oh, that's awesome. So Sergey, Natalia, and Judith, I think you should be in a lot, but there's one missing. One person only said a little here of you guys. So that's great. So actually 14 of the 16 people who voted said they have a little experience, which is cool. And 2 say that you have a lot. Now, the a lot people, it would be great if you could also monitor the chat and Slack and basically alert me if there are questions or maybe even answer them yourselves. If you know the answer, that would really help me out, right? Because it's a little bit distracting when I try to answer questions here in the chat while I explain some other things. So I really, really appreciate if you could chime in a little bit. And because Sergey is a little bit under the weather due to the booster, it would be really great, you know, if we would all stick together and help each other out when possible and if possible. Yeah, right. So Fatih wrote something in the chat here. That's all right. If it works, that's good enough. All right. Okay, just to check, have you all downloaded the GitHub repo? Do you have a folder with all the materials now? Should I create another chat? Another poll? Or you can also just let me know if that's all right. Yeah? Okay, fantastic. So I see thumbs up. That's great. I should have asked differently though. I should have asked who has not downloaded the materials and if there's any problems that you encounter. If you now give hands up, that would mean that you have problems, and we're happy to help you out. Okay? All right. Now, let's get started, right? So first thing is, I'd ask you to, in the folder that you've downloaded, let me share my screen. So that should look something like this on your computer. Is that correct? Can I get a little bit of feedback? Is this what the folder looks like when you've unzipped it? Thanks, Natalia. Awesome. All right. So I hope that if you double click on this thing, right, that RStudio should fire up, right? And then if you go to files, you should be able to navigate to the RMD files, so the R notebook files. And when you click on the with code RMD, then you should see something that looks like this. Does that work for you guys? If it doesn't work for you guys, it would be really fantastic if you could let me know. I'm looking at the chat, so if you've any problems, please let me know. Yeah, I don't see any problems. Does that mean now when you click on that AcqVA data with R WS approach file, when you double click on that, or just actually, I think it's a single click, then it should fire up. If you then click on the with code RMD, you should have something like this in RStudio. Is that correct? Or hello?
Yeah, everything works well.
Thanks so much. Please give me feedback, because I just can't look and look at your computers, right? So if there's any problems, the only way that I know that there are problems would be if you tell me. All right. Okay. So the first thing that you need to do when you work in RStudio is just install the required packages. So in RStudio, you would click on this play button here. And when I say run code, that's essentially what I mean, that you go to this little green play button, not this one, right, but this one, and then play it. So you only see the folder, right? So let me go back and share the folder. Oh, you mean in, now I know what you mean. All right. So you saw this, right? And you didn't see my RStudio. All right. So when I double click on this file here, the AcqVA data with R WS approach, right? When I do this, then I see something that looks like this. When I then click on this file. So first thing that happens is basically RStudio opens. And then you need to click on this with code RMD. And that will then open the notebook, which looks like this. And the first thing that you need to do when you are in RStudio is to press this play button. And that will then install the required packages. So when you work with R, essentially when you download R, you get a base version of R, which is only a very few packages are pre-installed. That's referred to as base R. And then when you want to do some fancy stuff, you essentially need to collect some other tools, right? And those tools are in packages. And so what happens is that basically if you want to do a little more complex stuff, then you install and activate other packages. And in those packages are the tools that you need to do to make some more fancy stuff. For example, because today we're dealing with data visualization, we need different packages for data processing and data visualization, right? And the package that we'll be using is called Ggplot2, and it's within this tidyverse package, right? And when you install the tidyverse, basically that installs Ggplot2 for you. The here package, you can do that for dealing with pathing. Pathing means that oftentimes you need to tell R where to look for example, for data. And the here package makes it much easier to look for data when you work with R. The VCD package that is used for creating mosaic plots. Mosaic plots are useful when you want to visualize several categorical variables at once, because it can be quite tricky to visualize categorical variables at the same time when you have several of them. And mosaic plots are one way to do that. And so I thought that later on, we'll have a look at the VCD mosaic plot functions. Then, because I know that many of you are also working with questionnaires, there's a package called likert. And the likert package is a very handy way for visualizing questionnaire and survey data. And so we're also going to do that in the second half of the workshop. And so you also need to install this likert package, right? It's very useful when we want to visualize survey and questionnaire data. Before the workshop, I also asked people to send in some data sets, and some people also asked if I could show them how to visualize effects of generalized linear models or other statistical models. And so in order to create a model, we use the elmi4 package. That's why we load this. And then we can visualize effects in that package using the sjplot package. And that's why we load that. And here actually, that we don't need that because we've already got it. Right. Just to explain a little bit about the code, right? So here, this is called a code chunk. And the code chunk always starts with these three kind of weird half quotation marks. I don't know what they're called. And then you have a curly bracket starting with R. And then you have some descriptions of what happens in the code chunk. But that's not super important. What I'm having here is just this code chunk contains R code. I call this code chunk install. So that's the name of the code chunk. I don't want to automatically execute it. I only want it to be executed when I really press the play button. And I don't want any messages or warnings to be shown when I render the document. What rendering means, we'll talk about this much later, right? And then you have, again, these three symbols, and they tell you, okay, now the code block is over, and you can actually do some writing. In case you can say something here, the code has ended, right? Okay. Now, with respect to what's going on within the code block, here you see that there's this hash sign, right? A pound sign. And that means that whatever follows, don't execute it. That was typically used if you want to add comments to your code, right? So here the comment is, the following will update R. And then I have also an install packages command. So it would install the install R package, but I've commented it out because you could do that to update R from within R, but I didn't want this to be executed right away. Then whenever you've installed a package, you need to activate the package. And that's done with the library command. The library command means activate a package from the R library, okay? And because I don't want to install this package, I also commented out this library command. So I don't want R to fetch this package from the library. And then here's a function called update R. And that would actually update R from within R, but I've also commented it out. If you ever want to update R from within R, then this would be the code chunk that you could use. And in order to activate it, you basically just need to comment it out. And now if I would press the play button, then that would be executed. And if you put the hash sign before any piece of code, it's commented out, which means that it's not executed. And here again, we have a comment which says install required packages. And then here we have an active line of code, which then tells, okay, I want to install packages. And in this case, I want to install the packages tidyverse here, VCD, likert, elmi4, Ggplot, and I also want the dependencies. So sometimes if you have tools, you can only use them if you've other packages already installed. And these would be dependencies because the package depends on other packages, right? And the dependencies equals true here means please install all the packages that are relevant for the packages that you want to install, right? And now if you do that, then basically everything is installed. Once you've installed these packages once, you don't need to do that again because they're stored in your library. It's just like buying a book. You also need to buy a book once, and then basically you put it in your library, and whenever you want to go and check that book again, you just take it out and you can read it, right? So once you've installed a package, you can just basically activate it and take it from the library. You don't need to reinstall it, right? This is why I commented out. This is why I used the command, the argument eval equals F. So don't evaluate this code chunk, only if you press the play button, right? Okay, so let's leave it there for a second, right? I'm going to stop sharing for a moment. And I'm going back to the Jupyter Notebook. Let me just go here. Bam. Right. So let me share my screen. Now on the Jupyter Notebook, you see I have the fancy cool graphic here that was rendered automatically when you put in the path to that. And then you see that actually it's very similar, right? So the similarity here is that you also have some sort of description that's in plain text, right? And then you have a code chunk. The difference is that here you don't specify the code chunk. You just create a code chunk, and then basically you have code in here. And because it took so long to install the packages, what I did here was that I created an object called T0, and that basically stores the system time. So basically it tells you now it's 7:40, right? Then install the packages, and then I have a second time command where it says now that it's finished, it's 7:42, and then when I subtract these two times from each other, I know that basically 2 minutes have elapsed, and it took 2 minutes to install the packages, right? And in the Jupyter Notebook, you should be able to just also press the play button, but it's not a green play button on the right. Here it's the play button on the left, right? Okay, now, do you have any questions? Are there any problems? Anything that I can help you with where you struggle? When you're completely quiet, I assume that you're all desperate at your computers and you're saying, oh no, nothing works. What's he doing? And I just don't know. Julia?
What if there is a problem with installing a package? It gives me an error.
Right.
What
could you actually share your screen? Is that possible, or do I need to make you co-host? I can make you co-host if that's okay.
I think I wouldn't be, well, I would need to stop Zoom because I'm using two computers, so I wouldn't be able.
All right. So in that case, like I assume that you're working on in RStudio, right?
Yeah.
So because of that, right, I created the Jupyter Notebook, right? Because I assumed that something like that might happen for some people, but I still want you to be able to follow the workshop. And that's exactly why I used the Jupyter Notebook. So what I'd like to ask you to do is I'll post the link to the Jupyter Notebook again in the chat. And what I then ask you to do is to follow in the Jupyter Notebook, because that way you can still basically execute the code and work in the code and see what it's doing, and you can be active, right? Even though there's a problem in RStudio, right? So in that case, I'd suggest forget about RStudio for the moment. We can have a follow-up meeting, and basically then I'll help you out with the installation and we'll get that sorted. But for this workshop, I'll then suggest that you work in the Google in the Jupyter Notebook on Google Collab. Now, it just takes 2 minutes to install the packages, right? So basically, if you go to the Jupyter Notebook, you press the play button of the first code chunk, and then it'll just take 2 minutes to install. That's just the disadvantage, that it takes some time. But I think it's actually worthwhile to do it that way then. Is there anybody else who has problems? I'd give you the same advice. If you encounter any problems with installing the packages, really try to switch to the Jupyter Notebook. And it would actually make sense to activate them both, right? Just in case maybe something goes wrong later. And then you can just easily switch if that's okay with you. Anybody else who I can help here? No? I guess you're all desperate and you hate me already, but now I just have to go through with it. So, all right, I'll basically go back to RStudio now. And after I've worked in RStudio, I'll then switch over to Jupyter and do the same thing there. But you should also be able to follow what I do in RStudio in Jupyter, because it's very much parallel. There are just some minor differences in the two notebooks. All right, let's go back to RStudio then. All right, so now you've installed the packages here. And now I really wanted you to have some early success, because I think it's really frustrating if you have code and you want to visualize something, but you don't really get to do that for a long time, which we have. It's 7:45 already. And so there's a very, very easy way to visualize data, which we do here in the primer, okay? And what I do here is I generate two variables, namely X and Y. And then I create a box plot from X and Y. And don't worry about the code. Basically, when I execute the code chunk, just I create an X variable, which consists out of numbers, and they vary from 0 to 1. So it's the numbers from 0 to 1, and it's always by an increase of 0.1. And it's a sample of those numbers between 0 and 1. And the Y variable consists out of basically not numbers, but here we have group A and group B. So basically we have numbers, and then we have group A and group B in the Y variable. And now if we execute this code chunk here, we've created our first plot, right? So actually it's very simple. We basically have two variables, and then we use the box plot command, which is in base R. So for that, you don't need to install packages. And here we say, I want you to create a box plot. And then within, after the box plot, we have these round brackets. And that means, okay, you have a function that's called box plot. And then within the function, you tell what the function needs. And the function needs something to visualize. And so we needed to visualize X and Y. Sorry. And then the tilde here is just to say, a way to connect the two in this box plot function. So have you managed to run this code, and do you see a box plot that looks something like this? If it works, please give me the thumbs up. And if it doesn't work, maybe do the clapping hands or something else. So it worked for at least some people. Awesome, that's nice. If you don't respond, or if something doesn't work, please don't use the thumbs up. Maybe use something else, like clapping hands or raise your hand, something like that. so I can see that, but I don't see any problems so far. Okay, now the problem with this plot is that it doesn't really look very nice, right? So it's pretty bland. It's gray and white and black. And so we want to make it a little bit more fancy, all right? Not super fancy, but at least a little bit more fancy. And now that you've created your first box plot, yay, we can elaborate a little bit on the code. So we do the same thing here as we've done before, right? But now we don't close the bracket, but we put in a comma, and then we can say, actually, I want different colors. And so there's an argument called COL for color, and that equals orange and light blue, and we put this into round brackets with the C for concatenate, right? And so that essentially defines that now the boxes will have different colors, namely orange and light blue. And then I want to give different names for the axes, namely now we have X and Y, which is not really that nice. So I want the X-axis label to be groups and the Y-axis label to be probability, right? And now if we execute that, it looks a little bit nicer. I like it, right? So this was basically the way that I visualized data for a long time, right? Can any, I don't have a Norwegian keyboard. So Brechtje has the question how to create the tilde on a Norwegian keyboard. Would really be great if someone else could answer that in the chat, because I have a German keyboard. It would be really great if someone could help her. Right, and so we have a little nicer graph, right? Now, switching back to, I'll stop sharing. What happened here? Sorry. There I am. Okay, cool. So now I want to go back to my Jupyter Notebook. Where do I have it? This looks like it's this, right? So here we have the same thing. So you should be able to execute this code and you'd see the same box plot, right? Just the dimensions are a little different, right? And here I've basically, yeah, you see it looks like this. We still have the axis labels. We don't have the nice color. So here we can execute it and it should look something like this, right? And so you have the nicer box plots here. So that's actually a very handy way to create plots in base R. Now the problem is, right, that you need to specify, or that different types of plots require different commands. So for the box plot, you use the box plot command. For bar plots, you use a bar plot command, which is very similar, right? And the plots are nice, but not super fancy, right? And so what happened is that basically there was a new way of visualizing data, which has become more and more popular. And the package that is used for those visualizations is called Ggplot. And so from now on, I just want to have you this success in the beginning. We're going to use the Ggplot package for visualizing data. And the data sets that we're going to use, we use 3 different data sets. One is called Data German, one is called L2 English Intervention, and one's called AJT_V2, right? So these are the data sets. And now I told you that when you install R, it comes really in a base form. So now that we want to do some fancier stuff, we actually need to activate the packages that allow us to do some more fancy stuff. So in order to do this, we again press the play button, right? And that will load those packages from the library. If you want to upload your own data in Google Collab, that's also super easy, right? So if you have another data set, you can do that by clicking on this folder symbol, right? And then you can upload another data set, right? So for example, I could upload the data set to Google Colab this way, right? And actually, in order for everything to work, you need to upload the data sets in Google Colab, right? So what I suggest you do when you work in Google Colab is you upload the data now so that everything works. So you go to the folder symbol, you navigate to the data subfolder in the folder where you have all the R stuff for this workshop, right? And then you can just highlight everything essentially, and then say open. And it will create a warning and will say, after the Jupyter Notebook is closed, everything will be gone, right? But that's fine. That's really fine. So now you have all the data here in your Google Drive, right? And now you can work with that. And so what we're doing here now is we are loading the data German data set. It's an Excel data set, and it was provided by Julia. Thanks a lot for Julia for providing some data. And in order to load it, you again just press the play button, and then you see this is what the data set looks like. So you have different variables here: ID rater, ID child, age group, accent response, accent numeric, rating language, age month, and family. All right. So this happens when you basically execute this code chunk. And what you do here is you create an object that's called my Xlsx. So my Excel dataset. And that object contains the result of when you execute this code chunk or this command. And here we use the read_Xlsx function from the readXL package. And that reads in this data set from here, right? So it loads this data set. And we want the first sheet in that Excel spreadsheet, right? And then basically you can use the head command to inspect the first 6 rows, right? So what we do here is we read in a data set, we call this my Xlsx, and then we inspect the first 6 rows of the data set using the head function. So the head function for any object that you put into the head function. So you do this by, head, open bracket, and then you put in a data object there. It'll give you the first 6 rows or first 6 elements of something. So it's a very handy way to inspect data sets, right? Right. And here we can also write data, right? So now remember that this data set is called data German Xlsx, right? And I've only stored it in R as something that's called my Xlsx data. Now, if you want to save data and store it here in your Google Drive, you can do this by not read Xlsx, by write Xlsx. And that requires 2 things, namely the thing that you want to save as an Excel file and the name that you want to give it. And here we'll call this my Xlsx, and that when we execute it, that will save the data set here. I'll just take a little bit to compute. All right. Actually, that takes rather long. Need to be patient here. Right. While the Jupyter Notebook is doing something, I go back to RStudio. For those guys who are working in RStudio, so I do the same thing here, right? So here I activate the packages, press the play button, and that fetches those packages from the R library. And then here I load the data set, and you see that here we have the same command. So the R is the same thing here. And then we inspect the data set. And here, there's a slight difference, right? When you work in RStudio compared to Google Colab and the Jupyter Notebook. So here, basically, I install the package a little bit later. And you see here that I use a different command, right? In Jupyter, we only had the name of the object here. But here, I use the here function from the here package, and we tell it that it should store the my Xlsx dataset, right, into the data folder, right? And just to show you what the result of this function is, let me just put this into the console here. So if I execute this, this means that it'll create a path. So R knows on your computer, where should I store that object, right? And in this case, it stores it on my D drive, in my uni folder, in my UAT folder, in the workshops folder, in the AcqVA data with R workshop folder, there in the data folder, and there it creates a file called my Xlsx Excel object, right? And so that happens when I execute this chunk of code. So it installs a package, it then loads the package from the library, and then it writes the object into my data folder. And if you check the data folder, you'll see that now there's actually an object called my Xlsx dataset, right? Okay. Because you not only work with Xlsx, you also work with CSV and other formats. I should actually call this CSV. So you can do that in the file in the RMD file as well. So here was actually a mistake. I had still the Xlsx there, but wanted as CSV. So here we can load a CSV file, and this time we don't use the read Xlsx. We use the read CSV file in order to read in a CSV file. But you see the data is identical, right? So it's just the same data set, but once I stored it as an Excel spreadsheet, and here I stored it as a CSV. Same here, if you want to then write it into your data folder, now you see here it's a CSV file. Oftentimes I actually store stuff in TXT, so in a tab-separated text format. And here I also can read in the data if it's a TXT file. And you see if I then check it, it's exactly the same. So it's the same file, it's just different formats. And if I want to save something as a TXT file, then I use the write table command, and I need to define the separator, right? So when you have tabular data in a TXT file, you need to tell it, okay, how are these cells separated from each other? And in this case, I use the \T, which means they're tab separated. So they're not comma separated or semicolon separated. They're tab separated, right? So I can do this here, and then you see there's a TXT file that was created. When I work in R, I actually often use create RDA objects. And the advantage is that they're super small. So even if you have maybe an Excel spreadsheet that's super large, that's like 50 MB, if I store it as an RDA object, it's super small. So then it's maybe 1 MB, something like that. So that's why I often use store stuff as RDA files. And you use this when you read in an RDA object, you use read RDS, right? And when you execute this code chunk, you'll see it's the same data, it's the same structure, same data set, it's just stored as an RDA object. And in order to save something as an RDA object, you can use the save RDS function, and you execute it, and now you see there's an my data RDA object. All right, cool. Now let's go back to the Jupyter Notebook. So here it's the same thing. We can load CSV files, we can write CSV files. And here, this means that there are actually 3 cells that are collapsed. And if I click on that, basically they'll expand. And now I can also read in a TXT file. I can write a TXT file. And again, here the same thing with the RDA. I can read in an RDA file, and I can write an RDA file. And they will appear here. Maybe not right away, but they'll appear very soon. Okay, you have, oh, right. So I need to share my thing again, sorry. So what I just did, what you couldn't see is I basically just played these code chunks here when I load the CSV file, here when I write the CSV file, here I load the TXT file, and here I save the TXT file. Here I read the RDA, and here I save the RDA. Now, Judith has got an error message.
Yeah, but the rest is fine. It's only the Excel file that causes problems. The rest is, yeah, works fine.
Okay. So can you read in the Excel file? Or not at all?
Yes,
Same
that works.
Yeah? Okay.
the same message as Judith. I don't know.
Okay, then forget about it for the moment. So I have to say that this is the second workshop only that I use the Jupyter Notebooks. I'm still a bit new to that. And I basically have no idea what that message means out of the top of my hand, top of my head. So I can't help you out with that right away. I hope that it would not cause any problems. Obviously, there's some. I'll have to look into that. It looks to me like you might have to set a path variable to Java, or assuming you've Java installed. Judith, do you know if you've Java installed?
Probably not, but I can check. So, but I mean, because the rest is working, I guess
Okay.
we can just we can continue.
Okay, cool. Now, before we get to the exercises, we'll get to the exercises. But oftentimes when we work with data, the problem is now that what we've done is we've created our first graph. We now know how to load data and how to save data, right? And now that the data is in R, oftentimes what you need to do is you need to change and manipulate the data in a certain way. You need to do stuff to the data so that, many people have the problem. All right, I'll actually have to look at that probably during the break. But oftentimes what you need to do is you need to do something to the data. Like, for example, create a new column, or basically only select certain rows given on the content of a certain column, right? And so here I basically wanted to give you the very basics, the most useful commands when it comes to data preparation. So what do you do with the data set in order to change its form, right? To filter out certain variables, create new variables, and so on, right? And so the commands that you can use are called mutate. That mutate creates new columns, or it changes an existing column. Filter chooses rows based on a certain criteria. For example, give me only data points that were produced by children younger than, let's say, 60 months, right? Select means, so filter means you basically look at the rows and you filter out rows based on a certain criteria. And select means from all the columns, select only certain columns, right? So you basically can remove columns that you don't need. That's what select is. Then group by means, okay, you want to, for example, create an overview of how many boys are in your data set and how many girls in your data set, right? And that means you would group by gender. So that basically it groups by the levels of gender, of the gender variable in that case. Summarize basically is a way to summarize data, and we'll see that below, right? So you don't need to be scared. Now, spread means that you have a variable, for example, gender, and you have boy, girl, boy, girl, boy, girl, right? And what spread will do, it will create a separate column for boy and a separate column for girl. So basically it takes that the content of the one variable and then spreads it into a wide format, right? So it basically spreads it and makes the data set longer. So it spreads it out. And the opposite of that is gather. So gather basically when you have, for example, boy, girl as separate columns, what you can do is you can say, gather the data, and then it will basically collapse that into one column, which is then called gender. And a super important function is the pipe. And the pipe can be read as and then, and you will see that a lot in the code that follows, right? So let's go over what this means in the code chunk below. So we take our data set that we call my Xlsx, right? So that's just a data set. And then we have the pipe. So we take our data set, my Xlsx, and then mutate. And I told you that mutate creates a new column, right? So take the data set and then create a new column that's called age, right? And in that column, I want to have the values of age in month divided by 12. So I have basically years and then the decimal version of month, right? And then I want you to filter out all children that are older than 8 years old. So I want to filter rows and keep only those where the age that we've just created is greater than 8, right? And then I want to select columns. Namely, I only want to select the columns age, accent response, and family. And store this in a new data set that we call new data, right? So this is what this code chunk does. It takes the data set, it creates a new column, it filters out certain rows given on a value, and then it selects columns, and then we create a new data set called new data. Now, if you play or execute this code chunk, it'll take some time, basically because it takes the data set and then does that. And then it will display the first 6 rows. Right. Now stop sharing here. And I'll go back to RStudio. For those who are working in RStudio, you have the same thing here, same explanation, and we can do the same thing here, right? So here we have exactly the same example. And here it works very quickly. And we see that now we only have the age column, the accent response column, and the family column, just like what we defined here. All right. And that's stored in a new data set that's called new data, right? And then we take this new data set, and now we want to group by family and accent response. And then we summarize the data. So we want to create a new column that's called N, and it contains basically how many observations there are of family and accent response. And we store that in a new data set called dataset2. And then we have a look at the data set. So let's look at that. So that's our new data set, right? And now then we group it by family and accent response. And then here the N is the number of rows for the different combinations, right? So here we have the family, which is bilingual mixed, bilingual Russian, and monolingual German. We have accent response, no accent, strong accent, and weak accent. And there's, for example, 9 observations in the new data set where children grew up in a bilingual mixed family, and they were rated as having no accent, right? So you basically take a data set, then you can group it, summarize it, and that's a way to get an overview table, all right? Now, I only showed that very briefly because that's not the main focus of today, but I thought it's very important because whenever you want to visualize data, oftentimes you need to manipulate the data to have a certain form. And that's what basically you can use these functions for, right? That's why I wanted to show you how to do that, because it's something that you do very frequently. So actually, data scientists say that 80% of the time you spend on just changing the form of the data and summarizing data and processing the data so that it's then in the form that you can, for example, visualize it. And so I thought it would make sense not to show the command for visualization itself, but also show you how to load data, because you need to get your data into R, right? And then show you the basic functions of how you can change the format of the data so that it has a format that you can then visualize. All right, cool. Now we're actually at the point where we can start with Ggplot2, all right? And when you use Ggplot2, whenever you create a plot in Ggplot2, you almost always use the function Ggplot, right? And this should be a little familiar to you now, because oftentimes we have a function, here the group by function, and then you have these things in those round brackets, and they are called arguments. And the Ggplot2 function, that needs a data set, right? So it needs to know, okay, what should I visualize? And you give it a data set. And then in so-called aesthetics, you tell it what variables or columns in that data set should be on the y-axis and what should be on the x-axis and on the y-axis, right? And when we do this, sorry, you get this. So now there's nothing in that visualization yet. You've just created an empty ggplot that knows that it's supposed to visualize the my Xlsx data, and it should put accent response on the x-axis and y and age month on the y-axis. And that's what it does. But it hasn't basically done anything yet. It just has created basically the plain plot, right? And that's how Ggplot works. So the way that it works is that you basically have different layers. You have the background, and then you add, for example, points, then you add text and lines and so on, right? So you can imagine Ggplot working like you have these see-through foils or slides, or what you want to call it. And you create essentially a base, and then you create a new layer with points and a new layer with text and so on. So it's really like creating your visualization layer by layer, all right? And that's the thing about Ggplot that makes it so powerful, because when you think about visualizations as consisting out of different layers, it makes it very flexible. The base R approach is very different. The base R approach is not that you have different layers that you add, but there it's more like a canvas where you just paint stuff on that canvas, right? And the way there is that you basically paint everything onto one layer, right? And so that's a difference in the philosophy of how the visualizations work, all right? Now, here we've created the background, the first panel or layer, so to say, right? And now what we do here is we do the same thing here, but then we say plus, and plus adds another layer, right? And when you want to visualize something in this empty or onto this empty layer, then you need to basically use a geom, right? So now what we have is we have a function that's called ggplot. We have aesthetics, which define the axes. And then we have geoms, which define what type of plot we want to create. And in this case, our geom is a box plot. So it's the same thing that we have here, but then we add box plots, right? So let's see how this works. Awesome. So that would be a way to visualize or to create box plots in Ggplot. Right. Okay, let me stop sharing again. And let's go back to our Jupyter Notebook, because I don't want to leave you guys hanging. Oh, what's the problem here? Right, okay. So here we have the new data set. And now we basically group it and summarize it as we've done before. Here, we create the first layer. And then here, you already see the result. And now we have the layer plus we have the geom box plot, right? Okay. Now, what should be obvious is that this box plot is not very nice, right? It's really, really boring. And you wouldn't publish something like this. You know, it's not really, yeah, it's pretty ugly. And so what we're going to do from now on is basically to prettify the plots, right? So now, just to recap what we've done, you've basically learned how to install packages, how to load packages. how to load different types of data, how to process data, to do something to the data. And now you've basically learned how to create very basic plots, right? Now there's 2 more things to learn with Ggplot. Essentially, it's 2 or 3. So one is really to save plots. How do you save a Ggplot? And then really how to prettify plots. And that's what we're going to do for the rest of this first part of the workshop, right? Okay, so saving plots. Now here, whenever you want to save a Ggplot, the easiest way to do that is to use ggsave, right? And the only thing that ggsave needs is a name, right? And in this case, if I save this, it will also appear here as basically an object that I've saved. It just takes some time to update, right? And now what you see here is what we can do is here we have NAs, so rows where we don't really have data, right? And so the first thing that we can do is to get rid of data, to get rid of the NAs, because we don't want them visualized, because it doesn't look nice, right? And the way to do that is, again, to use the pipe. So you learned here that you can use the ggplot command and then basically put the data set into the ggplot command. Another way of doing that is to take the data set and then you get rid of NAs, and you can use basically the drop NA function to do this. And then you want to create a plot, a ggplot, with the aesthetics. On the x-axis, you want accent response, and on the y-axis, you want age in month, plus another layer, and that layer contains a box plot, right? Now, if we do this, we get the box plot here, which basically has the NAs removed, right? Okay. Now I think it's time to stop real quick and to see whether you could follow. So I see that many of you had the Java error. So I'll have to look at that in the break. I think a solution is to reinstall Java. That should get rid of the problem, or to reset path variables, the path variable to Java. But I can't do this at the moment. I can't do this right now. So I hope that you can still follow. Is everybody here where you've created this box plot in Ggplot? Okay, I don't see any reaction. Can you tell me? Awesome, thanks so much. So it worked for some people. That's great. That's really cool. If you have encountered problems, like if you encountered errors or something, could you also let me know? Because then what I'll do in the break is I'll try to set up a meeting with you and we can try to work on this together. So is there anything where something hasn't worked, where you encountered an error? And I know it's super frustrating. So one thing when you're new to R, the most important thing is to not give up when you encounter an error. I know this sounds very, or that errors are really frustrating. I really understand that. I completely get it, but it's something that will get better over time, right? Basically, the more errors you encounter, the better you become at solving them. And after a while, you know how to solve most of the errors that you encounter, and they won't actually be any hassle to you anymore. So it's really, I know that errors are very frustrating. I just hope that you don't encounter the problems. Right. So you all are following more or less, because I don't see many more problems that you describe here. We'll get to the practical part. Like, I completely understand that you want to be practical and basically have exercises, and there are exercises here. But I wanted to basically show you how to do that first, and then basically let you go and have a go at the data, right? So I'm very sorry for being so frontal at the moment. We'll get to exercises in a minute, but I want to show you how to do stuff first and then let you loose. Is everything okay? Can I get some more feedback?
Yes, thank you,
Yeah.
dear Martin.
All right. There's nothing I can do about the connection. I actually thought that, so I received a message here that I'm breaking up. That's true. I thought about going to university. The problem is that my building closes and that I would have been thrown out in the middle of the workshop. So I have to do it from home. There's no other feasible way. So I'm very sorry. If I'm breaking up, let me know. Tell me, please repeat what you said. You broke up or something. That'd be super nice. I can only apologize if I'm breaking up. There's not much I can do about this at the moment. And thanks for the feedback. All right. So now let's look at this graph, right? So when we think about what we can improve, all right. So probably I'll switch back to our studio because there the graph is a little bit bigger and you might be able to see better. Oh, sorry, that was not the right thing. Here we go. All right. So here we have the box plot with the NA. Here we save the plot. And here it's actually, now we create a different path, right? So if you look at the folder structure, you see that there's an archive folder in which I stored old stuff. Don't look at it, it's ugly. And there's a data folder, an image folder, and an RN folder. And what's important here is the image folder. Because what we do here when we save images in RStudio, there basically we can use the here function again to say, I want you to save this image, which is called my first ggplot.png. So in this case, we're creating a PNG object, and I want you to store it in the image folder, right? That's what this does, right? And just to show you what the result of the here function is it creates a path, right? So it tells, this is where I want you to store the thing here that you've just created. And some of you might ask, okay, why are these double colons here, right? And the thing is that the second thing is always the function, and the first thing is always the package. So this means take the here function from the here package. Unfortunately, they are called the same in this case, right? And it will save my first ggplot.png in the images folder, all right? So then we basically got rid of the NAs here because we took the data set, we dropped the NAs, and then we created a ggplot object, and then we created this box plot, right? Now, one thing here which is weird is that when you look at the type of accent responses or accent ratings, we have no accent, then we have strong or S for strong accent, and then we have W for weak accent. And that's not really the way that you would display that, right? You would basically have no, weak, strong, right? So this is basically not the right order. And there's different ways to do that, right? One way to do that is to basically change the data set itself, right? So in this case, basically we take the data set, we drop an A, then mutate creates a new column, or it changes an existing column, right? And if you want to change an existing column, you give it the same name that the column already had, right? So here we mutate the accent response column. We make it a factor. The factor is basically of the same column with the levels no, weak, strong. So this is the order in which we want the boxes to appear, right? So not no SW, so no, strong, weak, but no, weak, strong. And we can also give labels to the factor levels, right? So these are the levels, and they can have different labels. And here we have the labels no accent, weak accent, and strong accent. And so once we've changed our data, we then create a ggplot, and we do the same thing we had before. Aesthetics are on the x-axis, we have accent response. On the y-axis, age in month, and then we have a geomed box plot, right? So if we do this, now what we have is we have not only the right order, but we've also made the tick labels, the axis tick labels, we've adapted them to be nicer, to not be no W and S, but no accent, weak accent, strong accent, right? But still, I think this graph would not be something that you would publish, right? So here we have the, yeah, I'll say that in a second. It's still not publishable because I think that the labels of the axis are not very nice, right? I think to use these all lowercase and underscores is not really a nice way to label axes, right? And so we can change the axis labels. And here I show two different things, right? So here we do the same thing as before. We take the data set, we get rid of an A, we then change the accent response variable into a factor with those levels and labels. And then we create our Ggplot with those aesthetics, the X and Y axes. We then create a box plot and then plus another layer. And the layer overrides this. So it's not just a layer, it basically gets rid of what was before on the other layer and basically creates a new one. And now in order to change the labels of the axes, we can use the labs function. And here we can just say, okay, label X as accent rating and Y as age and month, right? Now when we do this, we basically now have nicer axis labels, right? It's a little nicer. Okay, and here I wanted to show you something else. Namely, you don't need necessarily to change the data itself, right? Here we change the data and then we plot it. And here is another way, because we can change the axis ticks within the plot. So we don't change the data, we change the plot options. Here again, we take the data, we remove the NAs, we create a Ggplot with x-axis and y-axis. We create a box plot, we adapt the axis labels, and then we change the ordering and the names of the x-axis, right? So in order to do this, we use the scale x discrete function. And we say the limits are no, weak, strong. And then we add labels here. The labels are no accent, weak accent, strong accent. And when we execute that, basically we get this graph, right? So this is the same as before, but now we've basically changed the way that we do that. Here we have not changed the data. We've just changed the plot options. And here we've changed the data and then plotted the data once we changed it, right? Okay, again, not super nice. What can we do? Of course, add color. Color is nice. So a way to do that would be very simple. We again take the data, we drop an ace, and now in the aesthetics, we add something else, right? So here we create an x-axis, a y-axis, and we say that we want to fill something, and we want to fill by accent response, all right? And then basically everything remains as we had it before. And when we do this, we get basically colors. And automatically also there's a legend that's created, right? Legend is nice, right? But the legend now is not nice. We'll take care of that in a second, right? But now at least we have colors. Now, in this case, we wanted to fill the boxes. But sometimes when you have points, for example, and you want to color the points, you wouldn't use fill. In that case, you'd really change color. And then you can just, instead of fill, you could say color by accent response, right? And that would, I can actually change this here as well. But what this will do, it will change the outline of the boxes, right? So now it's not filled, right? But the color refers to the outer limits, so the edges, right? And thus, in this case, we should use fill rather than color. Okay, now the background is gray. I don't like gray backgrounds for some reason. And one way to do that is to do everything that we've done before, right? So take the data, get rid of an A's, create a Ggplot with aesthetics, X, Y, and fill. We create box plots. We adapt the labels. We put the x-axis into the right order with the right labels. And then we add a theme. And the theme will, this is theme black, white. So theme W. And that will create a plot where the background is white, right? Because it really tries to use only black and white until unless you specify color, right? Okay. Right, okay. Do you have any questions so far? Any major issues that I'm not aware of, that I should be aware of? Sergey, Natalia? Is everything going okay? Have I broken up? Hey guys. Hello? Can you hear me? Yeah? All right.
Yeah.
Sorry, I think I broke up. Can you tell me when I broke up? Like, did you still see where where we created colors and then the black and white background? The plot with a black and white? Yeah? Awesome. Did you encounter any problems? Like, does it work so far for you guys? No, it doesn't. Denise, where can you describe where the problem is?
Oh, I meant I haven't run into any problems.
Ah, okay. Sorry. All right,
I
cool.
said no. Yeah.
No worries. If you encounter any problems, let me know, right? Or give me some feedback, right? Okay. So let's go back and let's now go back to the Jupyter Notebook again. Right. So here, basically, we'll just execute the code as we go. Right. So the same thing here. We changed the access labels, changed the ordering within the plot. We added color. We changed the background to white. Right. So this is where we are. Okay. Now, this plot is already pretty nice, right? I think that would be nice. But there's a problem because the legend here basically doesn't have the right title. And here the levels, right? They don't align with the access tick labels, right? And so that's something that we should change before we publish that, right? And also, I actually like to have the legend on the top. It doesn't have to be on the top. I just want to show you basically how you can do that. So here, what you can do is everything is the same, right? But we change two things. So here, the theme _ BW, that makes the background white. And if we want to edit the legend, we need to use the theme, right? So because the legend is part of the so-called theme. So here we say the legend position should be top. So here actually we change that. And also the legend is a guide. So the fill guide, because here the legend tells us about the filling of the plot, there the guide legend, the title should be levels of accent, right? And if we do that, basically we get the plot that you've already seen. So now we've gotten rid of most of the problems, and the only problem that remains is that the levels are different here. Just to let you know, if you change the data, right, rather than adapting the tick labels in here, this would not be a problem. You'd actually now have the proper labels already on top. This is why sometimes I actually prefer to change the data before I plot it, because it can save time, right? Okay. Another way that might be useful is that here you see that the axis limits, it doesn't start at 0, right? And that can be a little bit misleading. For example, if you have trends that go up and down, but you only focus on a very, very tiny fraction of the y-axis, basically it looks as if you have great fluctuations, although actually it's almost parallel if you really take 0 into account. And so one thing that I'd like to do is to change the axis limits. And in order to do this, we use chord Cartesian. And here we say that for x, we wanted to go from 0.5 to 3.5. It doesn't have to be, but in this case, I just wanted to show you how you can adapt the x-axis in addition to the y-axis. And the y-axis there, I wanted it to be shown from 0 to 150, right? So here, with chord Cartesian, you essentially are able to change the limits of a plot, right? Okay. Now, what we've done up here is we've filled by accent response, right? But maybe you want your plot to have different colors. For example, you might want it to be in grays, right? Because the publisher asked you to provide all your figures in black and white, right? Then you shouldn't use fill like that. What you can do then is you can basically use this command, the scale fill manual, and for color it would be scale color manual, and you can add the values of the colors that you want to show, right? So here everything is as before. We take the data set, we drop NAs, we define the x to y axis plus the filling, we create box plots, we adapt the labels of the axes, we adapt the labels and ordering of the tick labels for the x-axis. We have white background. We move the legend to the top. We change the legend title. We adapt the limits of the plot, and then scale fill manual will basically change the colors, right? So we'll change it to red, blue, and gray. But you can basically put in other colors as well. And if you want to get an overview of what colors are available, you can just, I suggest you check or you Google colors are, and there'll actually be help sites that tell you what colors there are. And there's many, many, many different colors that you can choose from. And then you just write the name in here, and then you basically, have different options for choosing different colors. All right. Now, another thing that's very important, I know that most of you work with experimental data, right? And so this is a nice overview graph, but oftentimes when you are working with experimental data, you have different groups, right? So you have, for example, a control group and a test group, right? And you want to create box plots, but you want to separate between the control group and the test group, for example, right? And one way to do that is to use Facet Grid, right? And Facet Grid basically takes a tilde, and you can put something before the tilde and after the tilde. And in this case, I only want to do split up by family because that's a nice grouping factor, right? So now we have the strength of the accent rating. We have the age of the child in month. And then now we want to have separate box plots by family, right? So everything remains the same, right? You can just copy that again, and then you can execute that, and that will basically then split it up. Actually, you can use both. You can also use Facet Rep here. So we had a question here, what's the difference between Facet Rep and Facet Grid? Actually, I don't really know. I use them both. I use them both, depends. You can also use Facet Grid. If anyone knows answers to questions I don't know, please feel free to correct me or to post it in the chat and help each other out, right? Okay. Now, here's a problem because you see that the tick labels are overlapping, right? So that's not optimal, right? And there are different ways that you can solve this. For example, when you save the plot, let's go back to where we did that. It was at the very beginning, right? You can actually change something. You can say width equals something, right? Or width equals 6 and height equals 4, right? And then when it's saved, it will basically adapt the dimensions, and that can help you basically spread out the plot so that you don't need to change the direction of the tick labels. But I also wanted to show you how to do that because it's actually something that I find quite useful. And what you need to do in order when you want to change the direction or the angle of the tick marks, you basically need to put this into the theme, right? And there you can say the axis text for X, right? They're the text elements. These are text elements here. They should have a certain size, for example, size 8. You can also make it bigger or smaller. You can make it size 12, make it bigger, or you can also make it smaller. And you can define the angle. In this case, I wanted it to be the angle 90 degrees. So now that they don't overlap anymore, right? And that's the way that you change or adapt the direction or angle of the axis tick marks there, right? Okay, so what's the difference here? Change header of legend. We already did this, right? Did I do this again? No, I think that's a copy error. That's just because I did this rather late in the process, right? Here, I just wanted to show you how to change the levels of the title of the legend. All right. Okay, and again, you can save this, right, and make it, and it will be in the image folder. All right. That was horrible, wasn't it? But now you basically know how you can load data, how you can process data, and now you also know how to not only create, but also modify a Ggplot, right? And how to save it, right? So basically that is, I think, very important. That's the skill that you need to have, how to load data, how to process it, how to create a graph, modify it to match your needs, and then how to save it, right? Let's just go back to the Jupyter Notebook real quick. Right, so here I basically have the same thing, pretty much the same. The only difference again is that here I don't have an image folder, and that's why I use the name of the plot right away, and I don't need to use the here function, right? Because I'll just store it flat in this directory. Right, I'll just save it, and it'll be there soon. And now we come to the exercise. So now that I've shown you how to do that, what I'd like you to do is to work on your own graph, right? And for that, we load a different data set. The data set now is the L2 English intervention data set. That's the one here, right? And I did something else to help you a little bit with basically the data processing. So here I use mutate if. That changes something according to, if something is the case. So we load the data set, and then if it's a character variable, I want it to be a factor. Factors have levels. Character strings, essentially, everything is considered to be considered different. So you don't have levels. It's just, everything is considered different. Then I wanted the data set to be grouped. and then I wanted it to be summarized so that the X dataset, the dataset for the exercise, looks like this. So here you have group, control, and test, post-test, pre-test, test item, condition, grammaticality, grammatical, ungrammatical, and you have a mean of a response, which is yes or no. In this case, it was 0 or 1. And for each group, basically, you now have different numbers because I wanted it to be in a way that you can create a box plot, right? And now here I have basically created a box plot already. And you can create this pretty much with what I've shown you, right? And so the exercise would be, given what you've shown before, take the X data set and try to recreate this plot, right? Now, if you've copied the Jupyter Notebook, you can actually write in here. You can say X data, and then I take the X data and I create a Ggplot. Ggplot, of course. And there I need aesthetics. On the y-axis, there is test. On the y-axis, there is what's it called? Response mean. And then, oh, sorry. I want there to be a geom box plot, right? And if I execute this, there's, of course, I haven't loaded that. Sorry. Back. But this is essentially what I'd like you to do, right? You can already start working on it. And what I've done here is I've created a skeleton for you where everything that you need to do is there, but I've deleted the content, right? So basically here you need to fill in things, right? In order to create the, no, it doesn't work because I haven't done this. Yeah, so this would be the exercise. You can start from scratch, or you can also fill in the stuff here and basically try to recreate this kind of box plot. Let's go just back to RStudio real quick. And then there we go. All right, so here I can do the same thing. I'll just execute all the code chunks. And then I'll go back to the Jupyter once everything's set. And here I use the here function to save it in the images. Here I create the data set, and then here I can fill in the information. And once everything is in place, I can then, for example, comment this out because I don't need it. I'm not going to take this. Yeah, so this is something, this is your first exercise. I'd like you to work on that and try out what you've learned. And I'll be here and try to help you. Breccia asks, can you change the order of the colors in the legend? Yes. So the way that you would do that, let me share RStudio. Here we go. So let's check where we define the colors. That's here, right? There, basically, you can change it by just changing the colors here. Now, it would be blue, red, gray, right? or you could probably, what you were referring to is probably have something like this, right? You can really give it all the colors and all the different ways that you want. You can also say gray and then light blue, for example, and blue. And then you'd have basically from no, which would be gray. Oh, sorry. What did I do there? What did I do that? Ah, okay. Here I need to work with the old labels. The way to do that would be to just, let me go back here, to use this command to really change the data. That's, I think, the easiest way to handle that problem. And then you don't need this because this does the same thing. And now when we execute it, we actually have the order that we want, because now we've changed it in the data itself. And we've also adapted the labels up here, right? Now, the difference is that here I've changed the data, right? And here what I've done is I've changed the axis labels, right? And so there's a disjunct between the axes and the legend here. And it's, in this case, it's actually easier to really change the data. And then you have, basically you can change the order and adapt it the way you want. Does that help? Or Brechtje? Did that help?
Yes, I'm sorry. I put a thumbs up, but it helped.
Sorry, no worries. All good. Right, but that's a way that you can handle that. Right. Okay. I really would like you to try and work on this, but I'm also happy to help. Right. So if you have problems, yeah.
Can I add something?
Sure, absolutely.
Do we need to do something with this filter that you put in the skeleton, or is it just there? Okay.
Yeah, so you don't need to, but if you want to create the picture that doesn't show up here, but it shows up in the Jupyter Notebook, there we go. Bam. If you wanted to look at to make it look like this, then you'll need to use filter somewhere. That's why I put it in.
Let me see.
So, but you can try to basically recreate this and see how far you get, right? And maybe there's also another way to get to do what I did with filter in another way, right? So what I show is not the only solution to that, right? And again, this is only an example, right? But I thought that I've showed you how to do that, and now it would be time for you to practice that a little bit. Okay. And here we have the plot now. Also adapt it a little bit. Right? Now they have different colors. Do this. Make the background white. You can split it by grammaticality. maybe by condition. Right. We can also change this around. So it's really just playing around, right? To basically try and see what we've done before and try to adapt it, right? And execute different things and then see what you can do with that. Right. Okay. Right. Any questions so far? No? I'll just leave you to it. If you have any questions, please let me know. Very happy to help. And if not, just work away, play with the code, make some happy little pipes, maybe a sprinkle of filter, whatever you like, whatever makes you happy there. Oh, it's already pretty close to this picture. Yes, so that's what I used the filter for, right? So here, if you check, you have something that's called filler there. And that means that one of the levels of condition is called filler. So I didn't show you that. You were right. Actually, that's a very, very good point. I should explain this a little bit. So filter comes from the dplyr package, right? So here I just say, take the X data and then take the filter function from the dplyr package. We know filter, right? We've used it before. And I want you to not keep rows. Don't keep rows where the condition is filler. So the condition should be unequal, should not be filler, right? So now what the filter does, it filters out all the rows where condition is filler, right? And if you do that, then you get this, right? So you're absolutely right. That's a very, very good point, right? So equals equals, sorry. So if you write equal equal, that means is equal to or should be, right? And if you have the exclamation mark and then equal, that means not equal, right? So it should not be blah, 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 right? So in this case, filter all the rows where condition is not filler. And that's how, one way that you can get rid of this. You're absolutely right. I didn't explain this, right? Right. Has anybody already succeeded? I'm very sure. I'm very sure that some of you are extremely far. You probably have already this plot. No? Yes? Isabel, yes, awesome. Would you like to share your screen? I'll make you co-host. Just give me a second. So I've made you co-host. So Isabel, if you'd like to share your screen, you could show us.
I'll try to share it now.
Yeah. So you can show us your code that created the box plot, if you like. Yes. Oh, and you changed the colors. That's great.
Yeah.
Super nice. Well
Well, it looks-
done.
Or- So does it look correct?
Yes, that's super
Okay,
nice.
great.
Awesome.
Okay, great.
Cool.
Should I stop sharing?
Yeah. Anyone else who's managed that? Or maybe you've discovered something that you'd like to share. No? No? Right. Is there anybody who got completely stuck? Is there anyone who needs some help? Some pointers, maybe something that we can do to assist you. Oh, all right. Okay, now the first 2 hours are over. So what I'd suggest is that now we've looked at box plots, right? And I think box plots are very nice and they're very handy and they're frequently used, but of course there are other types of plots, right? But you'll discover that it works very similar to what we've done so far, right? So what I'd suggest is that now we take the break. We'll meet in 1 hour. You can use the same Zoom link. So I didn't change it. You can just, we'll just continue with the meeting, so to say. But I'll switch it off. I'll be back in an hour. And if you have any problems, anything that you'd like me to help you with in the meantime, I'll monitor the Slack. I'll monitor my emails. I'll just take a short break. And then we'll see each other in an hour. We'll look at other types of plots. And then we'll also look at mosaic plots using VCD and likert data. And we'll see how we can visualize effects in generalized linear mixed models. Does that sound like a plan? Boo! No? All right. So I see thumbs up. There should be something like a thumbs down, right? It's completely missing. Do you have? Right. So if you have any questions, yeah, please feel free to post them in the chat. We'll be back in an hour. Same Zoom link. I hope you learned something. I think we've gone over actually very important data manipulation and visualization stuff. Yeah, I hope you're not too frustrated with error messages and that you struggle through. I'm very proud that actually, you achieved some goals here. Thanks for the support. And then we'll meet back in an hour. Yeah. Yeah. I feel like teaching when no one's saying anything. It's just like in my lectures. That's all right. All right. See.
This is a good moment, Martin, to tell you that you're doing a really good job. I can only join today, so I'm just following it. I'm kind of, as what you said at the beginning, following the show, but I think you're really doing a good job.
That's very kind. So yeah, feel free to also say when I'm not doing a good job. That also helps, right? But yeah, thanks so much. That's super nice of you. As always, really great. And I'm very happy to help you, right? So see you back in an hour. If you have any questions, post them in the Slack. I'm available on email. I'll just take a short break. So I'll not respond right away. And then we'll meet back in an hour. All right? Work for you? All right. Bye-bye. See you soon. All right.